Scherenberg, who is an AI engineer at Prodyna. So, who has heard about infrastructure as code? Who has heard about infrastructure as prompts? Oh, just one person, so okay. So then that's a perfect session for you, and I try to keep it short. So Marcel, enjoy your session, the stage is yours.
Yeah, thanks a lot, Dennis. So hello, everybody. Thank you for joining us today. I'm very glad to be here. And I'm glad that you found yourself at this quite still relatively early session in the conference, which is good, considering that we're also still relatively early in the process of AI implementations and agents in particular. So we've kind of cleared out the child melodies, and now it's time to start implementing or to start adopting. And I think that some of you were already at the talk just before this one, which was held by Ricardo, which was titled From Theory to Practice when it came to agents. Now we're going even deeper into like the practical implementations, especially focusing on certain use cases, with the specific use case that I brought for you today being, as the title says, infrastructure as prompt. So kind of combining cloud with AI and putting all these pieces that we have in the modern technology stack together into like a cohesive whole. Just a short introduction on who I am and what I do and why I am here. So my name is Marcel Scherenberg. I'm an AI engineer and IT consultant at Prodyna SE. So I'll talk a bit more about Prodyna in a sec. But I'm generally somebody who was originally a data scientist. So if we can differentiate between like kind of a developer and software guys and the AI guys, I'm definitely more of an AI guy, at least originally. So I have had a few years or a couple of years now building AI solutions or data AI solutions in particular, with a focus on my responsibilities being designing and implementing AI software and infrastructure, especially in the cloud. But just a short tangent on that, it is important to note that nowadays what it means to build data and AI solutions has kind of morphed over the last few years. Back when I started out, it was like a very large focus on implementing your own deep learning models, like doing this with packages like PyTorch and TensorFlow. Then you kind of abstracted away the like the specific concrete layer architecture of neural networks into building with packages more built on top of those, like, for example, Spacey for natural language processing. And nowadays, of course, the big focus is on pre-trained models, providing context to these models, providing tools, and to make these work the way you want them to. And the real lever you have there, the way you achieve these AI models, putting this into production and creating real-world value, is through expertise in creating custom software solutions built on top of these foundation models, and that's kind of what we focus on in the context of Prodyna. And our mission statement is basically to build tailor-made software from end to end for our clients, incorporating all these different technologies and integrating it into an entire tech stack. And just to give like a short overview of where we are coming from and why this topic of like infrastructure as code, AI agents, for that very purpose is important to us, because we have a specific focus on the Microsoft tech stack as a Microsoft partner, specialized in things like digital app innovation, data and AI, and also infrastructure. We basically cover a lot of topics, and because this is all in the Microsoft context, is also why I'm standing on the stage today. So covering this pretty wide area of IT components means that since we want to implement custom software solutions, that kind of brings unique challenges with it. Meaning that a lot of the requests that we get tend to be something like this. Just a customer who says, well, I want to do like a cloud integration or a cloud move. I want to adopt this new technology that we get, or that we have the possibility to integrate nowadays. The same obviously for AI. This has been a large focus in the last couple of years, that customers want to say, okay, we have these new AI technologies. We now want to start using them. We want to start integrating them into our products. And obviously, like even broader than that, wanting to do process automation, having all these manual processes where you can identify that, hey, we have all these new technologies nowadays, why don't we start using them and start automating our processes? And all of it is understandable. Those are all very, very good things to want. It is important to get in on these technologies. However, as you can see, this is a very open solution space, because if you have requirements like that tend to be very broad, what do you actually build? Because the possible solutions that are on offer or that you can start building with is very varied. So I've brought this big picture, which I like to call a big picture because it's quite literally a large picture, and it depicts some of the data and AI-related services in Microsoft Azure and how they connect to one another. Mind you, this is not only data and AI-related services, but it's also a few months old, meaning that there are already like 20 new services, some services are already deprecated. Like, it's a very fast changing landscape. And so if a customer were to come up to us and say, well, I want to do data and AI in the cloud, this is basically the picture you could present to them as in, hey, here's what we could do for you. Now, where do we actually start and what do you want? Which usually leads to like some form of choice paralysis on the part of the client. So especially in the field of AI, what you usually tend to have, or what a lot of companies have run into in these last few years, is that they start by saying, well, I want to do AI, so they start building AI solutions. Then they find the data that they have and see, okay, what kind of AI solution can I find with that, or can I build with that, and then start actually finding the business solution or the business problem that this AI solution will then solve, which of course leads to, in quotes, doing AI. But it's basically just provisioning a bunch of stuff. You don't technically really know what you're doing with that, maybe. And the question is, does that really generate the value that you want for your business? Are you really not only doing AI, are you utilizing it efficiently to create real-world value? So what we instead try to focus on is going from a business problem standpoint. So starting with a business problem, then seeing what kind of data do we need to solve that business problem, and going from there to the actual AI solution that ends up solving the business problem to create value. And so not just using technologies, but applying all modern technologies for a purpose, not just for the sake of it. Same, obviously, for cloud. We don't just want to provision a bunch of cloud infrastructure you don't need or already have covered. So don't do just lift and shift, but try to find cloud-native approaches. But again, the thing with having a business problem is that somebody needs to state this business problem. So technically, all we need is clients to have a solid grasp of their business problems from a technical point of view. Sounds easy enough, right? Well, no, actually. So I don't think that's happening anytime soon on like a very large scale. Fact of the matter is that this process is usually like an iterative one. People find out what they need by being confronted with things they don't necessarily want. So instead, what you end up having in a lot of cases is like an iterative cycle where you have people who come from a more business-focused point of view, like business stakeholders. So this is still like a very simplified graphic that I have here. Usually you have, in addition to the business stakeholder, also like somebody like a project manager, a product owner, a scrum master. But basically you have somebody who states like these business-focused requirements, and then you have people who actually translate that into technical implementations, technical infrastructure architecture. So you have somebody like a cloud architect who designs infrastructure, but not necessarily directly implements it. For this, you have somebody else, like a cloud engineer, who actually writes like infrastructure as code templates, selects specific services that should be deployed, works on creating code for that. And this person has to work very closely together with a cloud architect in, again, an iterative process to kind of refine what should actually be used or deployed. And after that's done, you also have to consider things like SecOps, FinOps. Is that something that's both within the compliance framework that a customer has to work within, and also like financially viable going forward? Because this is also a big topic when it comes to cloud. Is this actually cheaper? Can we keep this up long term? So you also have to seek consultation there, and based on that, you often also have to kind of refine your original refinements, refine what the cloud engineer worked out, and again, going through a couple of circles there. So after that's done, you usually end up with something that you can actually deploy, and then you have a DevOps engineer who deploys the infrastructure, integrates that into like CI/CD pipelines, etc. And at the end of this one cycle, you end up with an actually like deployed cloud infrastructure in the cloud. now, as you can see, there are a lot of errors going back and forth, so this can take quite a while. Usually, it might take like 2 or 3 weeks, like a usual sprint cycle within an agile framework. So this is still very much simplified, and kind of the best case scenario where everybody's already onboarded, nobody's on vacation, nobody's sick. Realistically speaking, it can take a lot longer to actually start deploying cloud infrastructure that you want to start working with. And you have to run through this iterative process multiple times to really start getting the start on what you want to achieve going forward with your business solution. So why not use agents to improve this? Why not start implementing this first solutions via an agentic approach and then kind of start iterating on that? So these are kind of the reasons why agents are actually like a good fit for this, being that agents can take business requirements as natural language instead of like very specific technical requirements that you need to work out, and then turn them into initial deployments that can be used for like experimentation, for getting feedback, for iterating on and going towards like a focused long-term solution. They can also help with reducing communication costs for this initial phase. In a lot of cases, you actually first need to identify which person you need to ask which question, who can give an opinion on certain topics or give an evaluation. So by optimizing this first phase in like a secure environment, maybe an exploratory environment, you can cut out a lot of the middlemen that are involved with this. And based on this, it's not only like an exploratory deployment that you can create, but you can also persist that. So what a lot of clients that I've worked with in the past had is like people just deploying things everywhere, like via the portal and trying things out. But obviously, that's not like a very stable approach, especially long term. So you want to kind of move away from deploying things via portals, via GUIs, and instead focus on using AI to explore, to experiment, instead of doing things manually, because these are a lot of the places where you can save a lot of time going forward. So in terms of agent orchestration, so obviously this is a very complicated task that you need kind of a multi-agent framework for. I think most of you, or some of you, already were at the talk before this, where my colleague from Microsoft went into more depth regarding agent orchestration. So just a quick introduction on this. Usually you separate like bigger tasks into multi-agent patterns that include like a supervisor that orchestrates and plans and routes tasks, plus task-specific agents for having to handle specific problems. And this is also something that you can build like recursively. So if you look at like the concurrent pattern, all of these like task-specific agents can then again be like multi-agents that also consist of like an orchestrator and specific subtasks. So you can really start to build relatively complicated workflows. There are different frameworks for making this happen. Obviously, Microsoft Semantic Kernel is a very good one. If you want a standardized, easy integration with Microsoft services and Azure AI Foundry agents, etc. There are also other frameworks like Swarm from OpenAI, and LangGraph is the other big one that enables you to like get more in depth when it comes to the creation of orchestration graphs, doing like more conditional routing within the overall agent framework. So the overall agent framework that we developed for this very specific use case was focused on implementing agents that kind of resemble the different roles you usually have in a project. So what you start out with is kind of getting a UI and getting this UI to the client or to the customer. For this purpose, it's just a very simplified Streamlit UI, but obviously you can set that up in any kind of front end that you want to design. And then you have the cloud architecture that kind of communicates directly with the client or whoever wants to state the business requirements, kind of seeking out different clarifications that may be needed to map out the path towards the cloud infrastructure you want to deploy. After like the plan is cleared up, the cloud architect routes the task to the cloud engineer. The cloud engineer has access to certain tools, especially like the Azure CLI in this case, to see what kind of infrastructure is currently deployed and how you'd have to set up an infrastructure as code template to work in this context. And this cloud engineer has the task of generating infrastructure as code templates, for example, via Terraform or in line with like the Terraform syntax. And you also have a Terraform consultant here as somebody basically that the cloud engineer agent can call for up-to-date information on Terraform, like documentation, which is a very important part, because if you use models or LLMs for this purpose, they usually have a cutoff date that's, for example, GPT 4.1 is June of 2024, so it won't work, it won't necessarily work with like the most modern Terraform provider, so you kind of need to look up what the actual requirements, what the arguments, what options there are. And this is also usually like an iterative process. So if you've ever worked with like a coding assistant for infrastructure as code, you sometimes get these templates that you then need to like plan and apply. You see that something doesn't work, you need to get back to the like GitHub agent or whatever and go through multiple phases. This is basically something that we're trying to automate here by having a Terraform consultant that can search for up-to-date information via Bing. And after a valid template is generated, the cloud architect then has the ability to route tasks or route the generated template to the second FinOps engineer, who validates that it's not only in line from a technical point of view, but also when it comes to things like pricing and compliance for different compliance frameworks. And based on that, the cloud architect may demand remediation from the cloud engineer. After that, the person who states the business requirements can either like approve or deny the deployment. And once that is done, you have a DevOps engineer who can actually deploy the code into the cloud as infrastructure as code, like using Terraform, using that as a tool, and also like push and persist the code to some GitHub repository or what have you in order to keep using it and keep iterating on it. So as you can see, like a big focus on the kind of tool use that the different agents have. Nowadays, we're moving more and more towards tools instead of like the RAG implementations that we had in the last few years. So big focus on giving the agents the ability to kind of investigate the environment and feel out what information they may need. So that much for the theory. Now the question is, how does this actually work in practice? So I've brought a showcase scenario with me. So it's going to be a showcase, meaning that everything that can go wrong will go wrong. But for this case, it's like a very simple demonstration of like a web portal that I want to create with very simple requirements. So just web portal to upload and download documents, secure cloud storage, and we want GDPR to be enforced. For this, let's jump into the actual interface, if I can get it on screen, that is. Whoop. There we go. And I think you should be able to see it now. So basically what we have here is the infrastructure as prompt interface, where you can describe your infrastructure requirements as natural language, and you also have a sidebar here where we can enforce certain compliance settings and turn on and off automatic deployment. So what we want for this moment is I've created a demo scenario for this, for like the simple file sharing portal. And what you can see here is that the agent just asks to create like a web portal with very general language. Just I want a portal where a team can upload and download documents, just cloud storage, what have you. And then the cloud architect asks for clarification, because this is obviously like very broad. And you can either choose to give this clarification, or you can just say, well, no other requirements, and it will work something out itself. So for this purpose, I've prepared like an auto answer that also tries to use an existing resource group, where we can see this resource group currently does not have any resources deployed in it, and if everything goes well, then we'll see in a minute resources being deployed to said resource group. So let's take a look at the log stream to see where the agents are actually at currently. So as you can see, we originally had like the cloud architect asking for clarification from the user, then cloud architect routed the task to the cloud engineer. The cloud engineer generated a template for what it should deploy according to the cloud architect, and then the cloud architect tried to validate this via running Terraform plan, and as you can see, well, that didn't go so well, because the cloud engineer has access to like old information regarding the Terraform provider, so it uses some arguments that are no longer supported. And in that case, it can actually start asking the Terraform consultant about what to do about that, what to use. And you can see that the Terraform consultant then responds saying, this is no longer supported, don't use it, meaning that the cloud engineer then starts deleting that basically from the existing template and generates a new template. This is, again, has some unsupported elements that you can get out of this, meaning that the cloud engineer has to ask for consultation again. And this is basically an iterative process that can go back and forth a couple of times. Usually it takes a few minutes to generate a valid template. And based on that, you can then deploy that later on. So for the time being, we have to wait for a moment. What I also wanted to mention is that you can see that the agents that we are using for this purpose, like the SecOps, FinOps agent and the Terraform consultant, because they use very specific Azure tools, meaning like Bing founding via the Azure service, they are being created in with an Azure AI Foundry, and we can actually see the agents here that are being created with like the instructions that I've stored locally. So you can see that the instructions we have in here are also what I have in my local code, and I can basically create this using the SDK during runtime and then use them while that goes along. And now you can see that the cloud architect has validated the template successfully and has passed it on to the SecOps and FinOps engineer. And after all of that is done, we basically get a response back from the cloud architect with an approval request saying that our simple secure web portal for file sharing is now ready for deployment in Azure, giving a quick overview of what actually should be deployed, saying that like all GDPR requirements are met because, well, we have ticked that we want GDPR to be enforced here, giving something of an overview regarding compliance and cost. So there's also cost estimate here, so you can validate that before going ahead with the deployment. And if you're more into the technical side of things, you can download the Terraform template here and take a look at that specifically. So give me a sec. So you can see that we have a Terraform template here in VS Code, and you can see whether or not these are like the providers you want to use, the services you want to use. If you have more of a technical view, and if you want to apply this, you can just say something like, please deploy. And it will now route it to the DevOps engineer, so it says it's deploying our infrastructure. And you can see that the DevOps engineer now has the task of actually deploying it. This will again take a few minutes, so it's also running init, plan, and apply to then persist what has actually been written to the code itself. And you can see the plan output over here. If I can somehow get this to work. So so it's 10 to add, 0 to change, 0 to destroy, and now it's running Terraform apply, which again will take a couple of minutes. And while that is deploying, we can take a look at what kind of takeaways we had implementing this and what I want to convey to you going forward. So agents are here, they are easy to implement, and you have the kind of abilities to kind of start using them with just a couple of lines of code, especially if it's something like Azure AI Foundry, but it can be a little hard to optimize sometime. And you should really try to focus on creating real-world value through your agent frameworks and providing agents with the necessary tools and knowledge. So it's not always necessary or sensible to kind of optimize or to kind of automate the entire process with agents, but try to focus on where your actual time sinks are that are easy to avoid. So also defining the scopes of what your agentic solution should do and where human experts can come in. For example, generating this initial code that can then be reviewed by experts in order to kind of move towards more of a production integration pattern, and to make whatever agents you define modular and reusable, especially focusing on modern standards like MCP or A2A. But also to then iterate on your solution. So you both, in terms of the agents that you implement as well as what the agents create, both of these can be a solid foundation to start using more complicated solutions in the future. So let's see if this is, well, this is still running, but mostly because the app services always takes a long time to deploy. But as you can see, we now have an app service plan, a key vault, and a storage account deployed within our resource group, which weren't there before. So very quick, very easy. You can persist the code. It's being pushed to GitHub, to whatever you want. And, well, you can start working within a few minutes instead of having to wait multiple hours, days, or even weeks to do so. So let's take another look. I guess while we're waiting for the deployment, we still have time for a couple of questions. And if you have any questions like going forward in the next 2 days, our booth is right over there. So at the Microsoft stand, the big ProDyna logo. And if you want to discuss use cases with us or have any questions regarding this presentation, you're always welcome to swing by and follow us. And if you don't want to follow us physically, you can also follow us digitally on social media, that is. So if you happen to have any questions, now is the time. Dennis? Well, Dennis? Question? Anybody have any questions?
So he finished pretty early, right? So he wants to get some serious questions. So there was one hand raised already.
Hi. You use Terraform, but can you also deploy other templates, like, for example, biceps or?
Sure.
Yeah.
I mean, basically, the tool we currently have in place is Terraform. But again, it's like a modular architecture where you can replace the tool of Terraform with another provider tool. You can do the same for like the basic knowledge store. Again, what we have in the Terraform consultant agent is currently like the Terraform registry as the specific knowledge source. You can obviously replace this with another provider source, and it works the same way. So the important part is like the process behind it, and the agents are modular to the degree where you can just replace individual providers or tools.
Hello. In which form do you provide security requirements, compliance requirements, for example, SOX or GDPR?
Yeah.
You show an example that there are tick boxes like GDPR requirements. You can enable initially. Do you fit all the GDPR feeded into the context for initial requirements, or you have prepared, squeeze some things of it as non-functional requirements into your application?
I don't think I quite understood that, like acoustically speaking, but
I'm sorry, I'm trying to speak as loud as possible. Can you hear me?
Yeah, that's better.
Yeah. In which form do you provide GDPR requirements or SOX requirements into the context of your?
So this is also done via the Bing search that I showed earlier, meaning that the SecOps FinOps agent can basically look up current documentation regarding GDPR. So it can look up what is online on the internet and what's being published regarding that. So whatever framework there is on the internet, it can.
So it's searching through the whole GDPR requirements.
Yeah, so it has access to basically everything that's on the internet, which is the whole entire GDPR framework. So it generally, in terms of GDPR, it works relatively well. If you have very specific compliance requirements, that's something we can iterate on, like in the very specific custom software solution. But generally, it is capable of integrating other knowledge stores as well. So if you have specific documents that you'd rather use to have like a higher confidence when it came to actually retrieving the knowledge that you want, then that's also an option.
Thank you.
All right, thanks so much, Marcel. So Marcel will still be at the Prodiner stage over there, at the Prodiner booth, and is happy to answer follow-up questions if you want. So then thanks for joining. Next session will be Clemens Vastas discussing JSON structure.
Thanks a lot for coming by, and have a good conference.